Hey guys, and welcome to this lesson all about solving absolute value inequalities. Now there are going to be a lot of similarities to the skills we learn in this lesson to the skills we learned when solving absolute value equations before. So let's do it. So in our first example, we are asked to solve the inequality. The absolute value of x is less than or equal to 5. Once again, I don't like to focus too much on just the notation. I kind of ask myself, what does this even mean? Remember, the absolute value of a number is asking you its distance from 0 on the number line. So we're being asked to find what numbers have a distance from 0 that is less than or equal to 5, no greater than 5. Well, I'm thinking that, okay, if we move 5 units to the right on the number line, all the way to the number 5, I think the absolute value of 5 is 5. Its distance from 0 on the number line is 5. That's kind of as great a number as we can get, as big a number as we can get, and still make this inequality true. And if we go to the left of 0 on the number line, I think we get to the point where, okay, at negative 5, remember the absolute value of negative 5 is equal to 5 because this is 5 units to the left on the number line. And if we're looking for numbers whose distance from 0 is at most 5, it means we're looking at numbers contained in this region right here. I might even do some shading in this region right here, including 5 and including negative 5. And so this in pink, I think this is a graphical representation of the solution set to this inequality. And if we were to write this as a kind of inequality statement, I would say, well, x has to be between negative 5 and positive 5, including both of them. So here's kind of a notational representation of the solution set, and here is a graphical representation of the solution set in pink. And I just hope this makes intuitive sense. Right? We're saying what numbers are no greater than 5 away from 0? Well, you're going to go 5 to the right, 5 to the left, and everything in between, you're good to go. Okay. Now, what if we had something where, the absolute value of x is now greater than 6? That means we are trying to find all the numbers whose distance from 0 is bigger than 6. You have to be more than 6 units away from 0. So for instance, I'm thinking about 0. All of these numbers in here are no good. They're too small. They're not far enough away from 0. Here's the number 6. 6 itself is too small, but anything greater than 6, I think, is going to be far enough away from 0, right? Its absolute value is going to be big enough such that if you took its absolute value, it'd be bigger than 6. Great. Now, I think of negative numbers. These numbers are too small, too small, too small. 3, negative 4, negative 5, negative 6. 1, 2, 3, 4, 5, 6. Here is negative 6. Negative 6 is itself not quite far enough, but anything left of negative 6 on the number line is going to be far enough away from 0. I'm thinking all about distance from 0 in this case. And so if you're telling me that the absolute value of x, the distance from 0, has to be bigger than 6, I'm telling you that this number, x, has to be either greater than 6 or it could be less than negative 6. Right? These are the sets of numbers that are far enough away from 0 to make this true. You can say, x is less than negative 6, or 6 is less than x, if you will. That is a kind of notational way to represent the solution set. And here's your graphical way, thinking completely about just distance away from 0. And of course, we use open circles because this was a strict inequality. It wasn't greater than or equal to. If this had been greater than or equal to, we would have filled in the 6's. So all about the distance from 0 being big enough or the distance from 0 being small enough. Here we kind of have a circle of numbers close to 0 that do work. Here the numbers that are close to 0 do not work, so it's all the numbers that are far enough away. Okay, now what happens if we start mixing up what's in our absolute value? So here is the way I like to think of this. You read this as the absolute value of x minus 6 is less than 3. Here's the way I like to think of it. We are asking for all numbers whose distance from 6, right? The absolute value of the difference, you can just think of this as the distance, whose distance from 6 is smaller than 3. Okay, do we have a number line? I do. So I'm thinking we're trying to find all numbers whose distance from 6 on the number line is less than 3. So here's 6 on the number line. If we were to go 3 to the right, we'd have 9, which we know is too far, so I'm going to do an open circle. If we went 3 to the left, we'd have 3, which we know is too far, so that's going to not be included. But any number in between there, those numbers are within 3 units of 6 on the real number line. That right there in pink, that is your solution set to this inequality. And you can try any of these numbers, right? Let's try 5. 5 minus 6 is negative 1. The absolute value of negative 1 is less than 3. Hot damn. Hot damn. Any of these numbers in this interval will make this inequality true. Here is the graphical representation of your solution set. Here is the algebraic representation of the solution set. The negative 3 is less than x, which is less than 9. You can almost say x is between negative 3 and 9, not inclusive of those endpoints. So just completely using intuition and distance, right? This expression right here means the distance between x and 6. The absolute value of the difference between x and 6 is less than or equal to 3, or excuse me, just less than 3. And that's kind of the framework that I like to use to solve these sorts of inequalities. Here we're said, okay, the distance between x and 15 is at least 9. So 9 or greater. All right. So when we think about it that way, here's 15 on our number line. We know that we're looking for numbers that are at least 9 units away. So here's 24. Here is 6. These are the numbers that are exactly 9 units away. And we're looking for numbers that are 9 units away or greater than 9 units away. Exactly 9 units away and greater than 9 units away. Here's your solution set to this inequality right there. All right, how would we write it algebraically? You could say x is less than or equal to 6, or 24 is less than or equal to x. I think that is going to be the best way to write it algebraically. Once again, all about distance on the number line. Let's do 2 more. What happens if you have something like the absolute value of x plus 7 is greater than 2? And just a reminder that we can think of this as x minus negative 7. Aha! So I interpret this statement right here to mean the distance between x and negative 7 on the number line has to be at least 2. Aha! So here's negative 7 on the number line. We're saying that the distance from x to negative 7 is greater than 2. And I may have said at least 2. It's actually going to be greater than 2. So negative 5 is exactly 2 away to the right on the number line. That's not quite far enough, but any number to the right of that on the number line will be far enough. And I know that negative 9 is exactly 2 units to the left on the number line. Not quite far enough from negative 7, but any number further than negative 9 to the left will be far enough from negative 7. That's going to make the inequality true. And I always suggest, might as well try one of these numbers, see if it works. Right, what's a number to the left of negative 9 on the number line? I don't know, negative 30. And I think if we substitute a negative 30 right here, we're definitely going to get a true statement. So I would say x is less than negative 9, strictly less than negative 9, or negative 5 is strictly less than x. Awesome. So we got one more example to do together. I kind of want you to pause the video and see if you can do this one on your own. All right. So for this next example, I would totally rethink this as x minus negative 22. So the difference between x and negative 22, the absolute value of that must be less than or equal to 10. The big conceptual thing is to recognize this as, oh, the distance between x and negative 22 is at most 10. All right, here's negative 22 on the number line. Here is a number, negative 12, which is 10 units to the right. That number is included in our solution set, and any number that is closer to negative 22. Here is negative 32, which is 10 units to the left of the number line. That number is included in our solution set, as is any number closer to negative 22. So we find that our solution set in this case is all numbers between negative 32 and negative 12, inclusive of those endpoints. All numbers whose distance from negative 22 is at most 10. So that's kind of an intro to how to do these absolute value inequalities. I hope it makes sense. So that's it for this lesson. I hope you enjoyed it, and I hope it was helpful.